A very good day to our lecturer, Dr. Mohammad Suffian, Misaran, Misran. In this video, our group will briefly present our design of heat exchanger as part of our assignment 2. Our group consists of 3 members, which are Abel, Alfeuz, Anak, Donne, Amirah Asyikin binti Mohammad Sappa, and myself, Merissa Lim May Yin. What is a heat exchanger? A heat exchanger is a device that is used to implement the transfer of heat from one fluid to another. Thus, the conventional heat transfers are classified into 2 types of flow direction, where it is based on the orientation of the 2 fluid streams. One of the flow direction is parallel flow. So in parallel flow, both the fluids flow in the same direction, where the other one is called counter flow. In this case, the fluid flow from opposite end and in opposite direction of each other. According to Ranquet law, one of the most common type of heat exchanger is the double pipe heat exchanger. In this double pipe heat exchanger, it consists of 2 concentric pipes of different diameters, where one fluid will flow through the smaller pipe and the other flows through the annular space between the 2 pipes. Now, in order to determine the rate of heat transfer in a heat exchanger, we can use the formula of Q equals to UAT. But first, we must obtain the temperature difference, which is T. In this case, it is more convenient to work with the logarithmic mean temperature difference LMTD. After obtaining the temperature difference TLM, we can then substitute back into the formula to obtain the rate of heat transfer.
And good day. I am Amirah and I will continue the presentation with methodology and design simulation. First, let us take a look at the design requirement which shown in the table. The student will ask to design a heat exchanger with the aim to heat the water from 17 Celsius to 80 Celsius and the heated fluid is steam which is at 120 Celsius. Flow simulation. The flow simulation started by the set the initial variable of the design including the type of fluid, fluid properties, thermodynamic characteristic, and the material of the tube, and continue with the boundary condition of the design including the direction of flow, and the computational fluid dynamic CFD simulation was started and the temperature of water output will be observed. If the output satisfies the design requirement, the analysis was continued with the analysis of heat transfer based on the simulation data. In the design requirement section, the length of the tube will be calculated. According to the calculation shown, to heat up water to 80 Celsius with cross-section of 2.965 meters square, 37.75 meter length of heat exchanger tube was required. The flow rate of steam also determined by 0.3586 meter cube per second. Thus, for the simulation, the heat exchanger was designed as a double flow heat exchanger where the steam flow in the outer tube by 0.58 meter cube per second, which have been discussed before. The water inlet was at the opposite of the tube, which allowing the water to flow in the system with 3 kg per second. For this design, the copper was chosen as the material as it has high heat transfer coefficient of 386 watt per meter square Kelvin at 20 Celsius. In the CFD simulation, the heat transfer from the hot steam to the cold water can be observed by the temperature counter. The red region represents the hot steam flow throughout the system. When the heat transfer occurs, the temperature change from hot to cold and vice versa. We can observe that cold water change from blue region, which represents cold, to green, where the temperature of water outlet satisfies the purpose of the design.
Salam sejahtera, I am Alfeuz. For today's presentation, these are my content, which is include result and discussion. The purpose of simulation analysis is to specify the design to produce water output temperature at 80 degrees Celsius. The flow simulation is used for flow region in the double pipe because it is best suited to determine the temperature counter of static temperature. The red region indicates the hot temperature fluid, which is steam. Then the blue region shows that the temperature is at ambient temperature. From this design, the advantage that we observe is can determine the flow of fluid inside the respective tube. However, the weakness of this design is the cool fluid has higher flow rate compared to the hot fluid. Then, the comparison study is performed to evaluate the performance of double pipe heat exchanger design. The simulation temperature of water outlet and heat transfer will be compared with the theoretical value. It is found that the percentage difference between the simulation and theoretical result to be around 0.45 and 12.03 of water temperature outlet and heat transfer respectively. Thus, it can consider that this design is optimum as the error is low. That's all from us. Thank you.